Welcome to Mind Unlocked. I'm endlessly curious, and this channel is where we dive into fascinating stories, ideas, and discoveries from every corner of knowledge. We'll explore science, history, sports, psychology, philosophy, and countless other fascinating topics.
Welcome back to Mind Unlocked. Yesterday we talked history, the Library of Alexandria, and how humanity managed to lose its own knowledge. Today, we're zooming out, like way out. Today we're talking cosmology and answering one simple-sounding question that's actually going to break your brain a little. How big is the universe, really? Stick with me, because the numbers coming up are going to feel fake. They're not. Let's go. Where it all started. Before we talk about how big the universe is, we have to talk about how it got that way, and that starts with the Big Bang. About 13.8 billion years ago, everything that exists, all matter, all energy, and even space and time themselves started from an incredibly hot, dense point. And here's the part people usually get wrong. It wasn't an explosion happening inside space, like a bomb going off in an empty room. There was no room yet. Space itself came into existence and started expanding everywhere all at once. The universe didn't expand into anything, it just started being bigger. In the first fraction of a second, the universe underwent something called inflation, expanding at a speed that makes even light look slow, stretching itself out enormously before settling into the slower expansion we still see today. About 380,000 years later, things had cooled down enough for the first atoms to actually form. Before that, it was too hot for electrons to even stick to nuclei. And it took a few 100 million years after that before gravity pulled matter together tightly enough to ignite the very first stars. We actually have leftover proof of all this, still floating around today. It's called the cosmic microwave background, a faint glow of radiation left over from when the universe first became transparent, and it's been measured and mapped in incredible detail. It's basically a baby photo of the universe. So everything we're about to talk about, stars, galaxies, all of it is stuff that came out of that original moment stretched across nearly 14 billion years. And it's still expanding right now as you watch this. Okay, now let's talk about just how big all of that turned into. Let's start close to home. Earth feels huge. You could spend your whole life on it and never see it all. But the sun could fit about 1.3 million Earths inside it. Not stacked next to each other, inside it. Like Earth is a marble and the sun is the bag. And here's the twist, the sun isn't even that impressive by star standards. It's basically average. There's a star called UY Scuti, a red supergiant. And if you swapped it in for our sun, its surface would stretch out past the orbit of Jupiter. Our entire solar system would just be living inside one star. Fact 2, our fastest spacecraft is barely out the driveway. Light travels at 186,000 miles per second, and it still takes 8 minutes to reach us from the Sunday. Voyager 1, humanity's farthest traveled object, has been flying since 1977, and light still takes over 22 hours just to reach where it currently is. That's not even the edge of our solar system. Here's the fact that really puts it in perspective. The nearest star to us, Proxima Centauri, is 4.2 light-years away. If Voyager 1 were headed there, it would take roughly 70,000 years to arrive. That's how close actually is out there. Our entire galaxy is just average. Zoom out further and you hit the Milky Way, home to somewhere between 100 and 400 billion stars, about 100,000 light-years across. Sounds massive. It is. And it's also completely unremarkable. Not the biggest galaxy, not the smallest, just an average one. Fun bonus fact, our nearest major neighbor, Andromeda, is on a slow collision course with us, expected to merge with the Milky Way in about 4 billion years. Don't panic, though space is so empty that individual stars almost never actually collide. More of a slow, silent dance than an explosion. Fact 4, there are trillions of galaxies. Here's where it gets genuinely absurd. Scientists estimate there are about 2 trillion galaxies in the observable universe, each one packed with, on average, hundreds of billions of stars. We are one planet, in one solar system, in one galaxy, out of 2 trillion. The universe is bigger than its own age should allow. And here's the fact that breaks people's brains the most. The universe is about 13.8 billion years old, so logically, the farthest we could ever see should be a sphere 13.8 billion light years out in every direction, right? Light's only had that long to travel, except space itself has been stretching this entire time, expanding the distance between us and that ancient light while it was still traveling toward us. So the actual edge of the observable universe isn't 13.8 billion light years away, it's about 46.5 billion light years away in every direction. That makes the whole observable universe roughly 93 billion light years across. And that's just the part we can observe. The real universe beyond that could be far bigger, could be infinite. We'll never know, because the light from anything farther away simply hasn't had time to reach us yet, and depending on how fast the universe keeps expanding, some of it never will. The point. So why does any of this matter? Honestly, it's not really about the numbers, it's about perspective. Whatever's stressing you out right now is happening on a floating rock orbiting an average star inside an average galaxy, one of 2 trillion inside a universe so big that even the visible part would take light 93 billion years to cross. And somehow, out of all that emptiness, matter arranged itself into something that can look up, do the math, and actually understand how big all of this is. That's you. That's genuinely wild if you think about it for more than 5 seconds. That's the scale of the universe, or at least as much of it as fits inside a human brain without short-circuiting. Tomorrow, we're going from the edge of the universe straight into your own head, talking about the Zeigarnik effect, the weird psychological reason unfinished tasks just won't leave you alone. See you there.
The world is full of questions waiting to be explored. If you're curious enough to ask them, you're in the right place. This is Mind Unlocked. I'll see you in the next one. Stay curious. Like, share, and subscribe. Also feel free to drop a comment in the comment section.